Just so I can post it on Canvas. Yes. All right. So your first rule is you got to factor everything. Okay. Notice it says though if needed. So are there sometimes it won't factor? Yes. Okay. So this right here, number 2, is the biggest thing. You can cancel factors, not terms. Write that down, and then I'm going to talk about what I mean. Okay. That is the most common mistake right there in this unit. Okay.
So is it like similar to like the president can veto something, but the Congress can override that veto?
I can't think of a connection there. No. All right, so here's what I mean. All right, so if I write this, 3x squared times x plus 4, okay? Factors are anything that is multiplied by each other, okay? So do y'all agree that this says 3 times x, not 3 x's? But do you agree there's a multiply between all of these things? Is there a multiply between x and 4 right there?
No, not x.
That's a minus, right? Okay, so x and 4 are both terms. Okay, so listen to my words here. X and 4 are terms because they're being subtracted. They could be added as well, okay? Factors are multiplied by each other, okay? So if I said, what are the factors in that? You would tell me 3 is a factor, x is a factor, x is a factor, and then x minus 4 together is one whole factor, okay? Questions on that? Whereas if I said, what's a term, you would tell me that x is a term. That 4 is a term. But together, they make that whole factor. Okay? Questions on that? And as we do more, I'll keep trying to show you the difference between a factor and a term so you know what you can and can't cancel out. Okay? All right. So we're going to stop there on our directions and just look at a couple simple examples. Okay? So open this up. Look at number 1. Okay?
We're not finished with the notes yet.
No, not yet. Okay, we're just gonna talk about those 2 steps first. Okay.
12x divided by 18.
Mm-hmm. So if I look at number 1, when I say factor everything,
You factor out 4.
Oh, that's
No.
can I factor anything on the top? So when I say factor, I mean look for a GCF. Hold that thought 1 second. Look for a GCF. Is it difference of squares? Do I need to make a box? Can I do any of that?
6.
Well, there's only one term, right? Do y'all see what I'm saying? So is there more than one term on top to pull out a GCF? No. So can I factor anything there if it's just one term?
What do you mean by one term?
12x cubed is one term together.
You can't. It's not like it's 12x cubed times.
Plus something.
Or yeah.
Like if it was 12x cubed plus 4x, then that would have a 4 and an x in common, right? But there's one term, so I can't factor anything. What about on the bottom? Okay. So this is actually, if I gave you this in Math 1, you could do this in Math 1. We've got to, some of y'all were saying divide out of 6 or something, I thought I heard. Yeah. Why? What would happen to 12 and 18? Could you reduce that? Because you divide both by what? So you're just reducing your fractions here, okay? So in a way that you can also think about it, just the numbers. Desmos will do the numbers, but it will not do the variables, okay? So let me show you why you are dividing by 6. Do you agree 2 times 6 is 12? 3 times 6 is 18?
Yeah.
What do they both have in common? So when y'all are saying divide by 6, that's what you are doing in your head, that right there, when you're simplifying fractions, okay? All right, do you agree on top that is x times x times x? And on bottom is x times x? Okay? So here's a factor, here's a factor, here's a factor, factor, factor. What's a factor that I circled on top and bottom? This x, right? And this x. Do y'all remember canceling things like this in Math 1?
No, 1x.
There's 1x left. Where? On the top or the bottom? And what numbers are left? 2 on top, and what's on the bottom? 3. Now, in Math 1, what you did is you were dividing, so what did you do with those exponents? Anybody remember that? How did we get just 1x? What do you do with that 3 and that 2? Subtract them. That was your exponent rules in Math 1 and Math 2, which still applies here, right? We're still doing math. Okay? So, you can simplify your fractions, and if you need to write out the x's and see how many cancel, do it. Okay?
So it's 2x
Over 3. Mm-hmm. That's your
it.
answer. That's your answer. Yep. What's your question?
So you write out the x's on how many of the x's are like.
If you need to, yes. Some of you can look at it and see x cubed and x squared and know that there would be 1 left on top. If you need to write it out, write it out. Okay? All right, look at number 2. Put the what? No. Look at number 2. Can I factor any more on the top? They've already factored a little bit for you. Can I break down 2x plus 1 any? Mm-mm. What about the bottom?
No.
Mm-mm. So they factored everything possible, okay? So tell me a factor that's on top. What's one thing that's being multiplied? 20? What's something else being multiplied? On the bottom, right? What else?
2x.
Keep going.
Plus 1.
Because that is an entire factor, right? In order for 2x plus 1 to cancel out, you'd have to have exactly what on the bottom? 2x plus 1. Okay? And then another factor is x plus 3. All that is grouped together. That is one whole factor. Okay? Can either one of those cancel? Do you have an x plus 3 on top? Nope. Do you have a 2x plus 1 on bottom? So can you cancel any of those? Mm-mm. Can you? Is just x right there the entire factor? Mm-mm. That's a term. Okay, so there's the difference. You cannot do this right here. Okay? Watch. And this is very common. It's okay. Because that x is part of a term, not the entire factor. Okay? Do you see the difference there? All right. So I know these are going to be left on the top. So I know I'm going to have 2x plus 1 on top because I don't have a 2x plus 1 on bottom. And I got an x plus 3 on bottom because I don't have one on top. Now let's work on that 20 and that 10. Do you agree that 20 is really 2 times 10?
Yeah. Should have about 2.
Well, what's on top and bottom now? Do you see a 10 on top and a 10 on bottom? So what does 20 over 10 reduce to?
2. Wait.
Just 2, right? Yeah. Because don't they both have a 10 in common? Okay. All right, questions there? That's the answer. That's all you got to get. Okay. All right, let's try to get maybe one more. Well, the only thing that they had in common on top was a factor of 10. Okay. All right, so look at number 3. X plus 4, can it be factored any? Does it have a GCF? No. It's 2 terms, but it's not a difference of squares, okay? So x plus 4 is the top. Ooh, now look at the bottom. If I don't cover it all the way up.
That'll be just x.
X and 4.
Okay, I like x and I like 4.
Why is it negative?
And then what's your other factor?
Plus 4.
Because what do we call that? Remember that's difference of squares? Okay, so this one we actually had to factor something, okay? All right, so let's talk about our factors. What's the entire factor that's on top?
Wait, what is x minus 4 and x plus 4?
It's because 4
Right there.
times
That's how
4
you-
doesn't exist.
That's difference of squares.
Why did we bring 4 into that?
Yeah, I don't.
But like the other one is 2 times 10.
Guys, this is factoring. This is old stuff. Look right here. So we had 2 terms, right? Was it difference of squares? Was there subtraction in the middle? And x squared and 16 were perfect squares, right? Square root each term. What's the square root of x squared? X. What's square root of 16? 4. And then remember that pattern? One's plus, one's minus. Okay, that's your difference of squares. That does not go away. You will see that a lot. Okay, so the 4 came from where? Where did I get these 4s from? Square root of 16. Where did I get the x's from? Square root of x squared. Okay. All right, so that is an entire factor on top. What's one factor on bottom? Tell me one.
For x minus 4.
Good, the whole thing, right? What's another factor on bottom?
X plus 4.
What did I circle that's on top and bottom that is identical? So what can happen to those whole things? They mark out. Where is the x minus 4? On the bottom. Now, we can't just leave it blank on top. What's really, if I put parentheses, what's really out here in front that we don't have to write? A 1. There is still a 1 on top. So if everything in the top cancels, there is still a 1 there. Okay? That's my answer. Now, how can I see if it's right? You might know?
Desmos.
What could you do in Desmos?
Uh,
Plug what in? You're right.
yeah, play easy.
If you plug this in and it'll create some funky graph, right?
Yeah.
And then if I plug that in, it should create what kind of graph? The exact same graph, right? If it doesn't, then you know something's wrong. It is. Okay? All right, one more thing. Write this down before we go. Okay? Flip back over to the front. I think that's what I want to... Yeah. All right. Ooh, that is blurry. All right, so write this down. If two factors are close to canceling, factor out a -1. Okay, write that down and we'll show you what it looks like. That is really small, isn't it? I'm going to write that a little bit larger. All right, and I am rewriting this because it is extremely small right there. That's what that little blob right there says, okay? So when I say close to factoring, that's what I mean. Do y'all agree that the top and the bottom look very similar? X minus 2 and 2 minus x. Do they mean the same thing, though? Mm-mm. Because when you fact, order matters, right? So on the bottom, if I factor out a -1, that means I'm taking both of these terms and dividing by -1, right? Okay. What's 2 divided by -1? What's negative x divided by -1? What kind of x? Now, look at that. Are those factors exactly the same now? Yes. Are you going to see that a lot? No, but it can happen. That's what you can do. Okay? Sound good? All right, when we get back, we'll finish this real fast. All right, right here.
Hey, y'all need to quit playing on that computer.
All right, so we talked about number 3. If you have two factors that look similar and you need to switch their order, you can factor out a -1. It's not going to happen a lot, but it can occasionally happen, okay? And then the last thing is you always want to make sure it is fully simplified, meaning there is not a factor on top and on bottom that can be canceled, okay? All right? So write that down, and then we're gonna look at number 5, and then we're gonna go to 4 and 6. There's a reason I'm doing it in that order.
My brain is hurting.
You'll be okay. All right, so look at number 5.
Oh, 5 has more.
It has a lot going on. The nice thing though is it already factored for you? Yeah, it's already factored. So step 1 is already done for you. Okay. Tell me a factor that is on top. X minus 5. What else is x plus 3?
X plus 2.
So all 3 of those are factors, separate factors, right?
Yep.
Okay. Tell me a factor on the bottom. 5 minus x, 2 plus x. So you got 3 factors on the bottom, right? Do you see any factor in yellow and in purple that are identical?
Yes. 2 plus
Okay, so can I say that this is also x plus 2?
Oh, and x minus 5 and 5 minus x.
Are those identical? Think of the value. When I say identical, if I have 3 minus 5 and 5 minus 3, are those the same values? Mm-mm. But if I have 3 plus 2 and 2 plus 3, are those the same values? So can I cancel these two out? Yes. Okay. So I can cancel those. Those have the exact same value. Okay. Now, these are similar, right?
It's just
Yeah.
Which is what I was talking about here. Do you remember how those were similar but not identical? How did we get this to switch order?
Minus 1 or divide by 1.
Mm-hmm. Because if we rewrite this, that's the same as negative x plus 5, right? Y'all see how I can just switch the order of those terms? And if I think about that leading term, it's what kind of number? Negative. When we did GCF, if your first term was negative, what did you factor out? A negative. Which means that x now becomes what? And what does that 5 become? Uh-huh. So now on the bottom, I have this. Now can this and this cancel out? Yes. Okay. So what's the only thing left on top?
X plus 3.
X plus 3. This I rewrote, right? So I don't want you to think it's still there. It's not there anymore, right? We rewrote it. What else is on the bottom? X minus 8. What else is still on the bottom? And don't forget, what did we factor out? A negative 1. Okay, so everything that was left, I'm circling. Okay, if it's left, you put it, if it was on the top, put it on top. If it was on the bottom, put it on the bottom. And that's as far as you can go. Okay, why can I not do this? This is very common.
Wait,
Because it's not one, it's in one whole term.
That is a term of a whole factor, right? Now, if that was this on top, could I factor x minus 8 out on top and bottom? Yes, if they were the same. Okay, are we good on term versus factor? Yes.
is it okay if we put parentheses around x plus 3?
Absolutely. That means the exact same thing. Yep. That means the same thing. Okay. All right. Questions on that? Because that was already factored. You just had to figure out what you could mark out. What you got?
Can we solve that?
You mean like distribute? You could. You don't have to, though. Okay.
So cool.
All right. Now, the last two are going to be kind of like your level 3. Those are what you've got to be able to do for our graphing part that we start tomorrow, okay? So if you look at number 4, check out the top. So right now, I only care about this yellow part. What's my first thing I got to do? In fact, I'm going to cover up the bottom. I don't even care about the bottom. What's our first step back on the front? Look for a GCF because that's part of factoring, right? Is there a greatest common factor? How many terms are there? 3. So when I look at my flow chart, what does that take me to? What do I need to make? Box. Okay. I'm going to get you started and then you're going to finish. What goes in the first part? What goes in the last part? All right. What do they have to multiply to?
Negative 2x.
Ooh, be careful.
Oh, yeah.
Negative 3x squared, right? Remember, it's these right here. And what do they have to add to? That comes from over here. Negative 2x. All right? You guys get those factored. Fill in that diamond and then fill in your box. Okay? So get that completely factored. Notice I care nothing about the bottom right now. What numbers have y'all used?
Negative 2, 1, 1.
Now remember, they got multiplied to 3. Negative 3.
Oh.
Oh, yeah.
I heard 3 and 1. Tell me this, fix the signs. Good. Because those would add to -2, right? All right, so -3x, 1x. How do I find this? Because it's the greatest common factor of that first row. And then finish your puzzle. Okay? So what is one factor? X plus 1. Okay, I'm going to write it right here. What's another factor?
All we're doing is send these to 0.
You don't even have to do that right now. Okay? All right, so notice all I've done is factor the top. Have I done anything with the bottom of that fraction? Nope. Okay, can this factor anymore? Or are we done? We're done. Okay? All right. Now, let's do that one. So I'm going to cover up the top. I don't care about the top anymore right now because I'm done with it. Go through those steps. Is there a GCF? Nope. So go to the box. Okay. Yep, we're still on the same question. It's kind of like you have 2 problems in one at the start, though. Okay? Oh, let me scoot it up some. All right, so now we're working on the bottom. All right, has anybody figured out
Yeah.
what do they multiply to?
Oh, -6x squared.
And they have to add to.
-x.
Okay. So what numbers?
2, -3.
2, -3. What do y'all think? We okay with that? So 2, -3. -3x. 2x. You already solved it? X. Once you get the box filled in, I think y'all are good getting outside, right? Some of y'all could probably do this in your sleep by now. All right. So I'm writing my factors from my box. Okay. All right. Is the green factored completely? Can I do anything else? Mm-mm. Okay. So everything's factored. So now, what can cancel? What factor is exactly on top and bottom? X minus 3 and x minus 3. They have to be identical. If one's a plus 3 and one's a minus 3, that's not the same thing, right? What is our answer? X plus what on top? 1. What's left on bottom? X plus 2. Could you put parentheses around the top and the bottom? You could. Okay. Because they're all a factor together. If you like getting in that habit, do it. You'd rather do like that so you know it's all one factor together, do it. Okay? All right, what do you think about that? Do you see now why we've practiced factoring so much? It never goes away, okay? All right. If I wanted to know if it's right, remember what you can do. If you graph this and you graph that, what should happen? It should make the exact same graph. If it doesn't, something's wrong. Okay? All right. Let's do one more, and then we'll stop. So look over at number 6, and go ahead and factor the top of that. Okay, I think a couple people are still writing. So look at number 6 and factor the top. Okay. Remember, what's the first rule of factoring? GCF. What else do you need to take out? You're right. What else do you need out there with that 2? Uh-huh. Brennan said the GCF was 2x.
Yes.
Y'all agree?
I agree
Okay.
with Brendan.
See. Which leaves us what? Perfect. Can I do anything else with that x plus 5? It's x to the first power, so it's done. Okay? All right, let's look at the bottom. Okay, so I can take an x out. Y'all agree with that?
Yeah.
Question is what type of thing? Just a positive X. Can you be quiet and let me think?
Zach?
That was so rude, Zach.
I know.
It ruins the bond.
You tell him, Zach.
He told you that.
All right, I've taken out the GCF. Can I still factor what's in the parentheses? How many terms are in there? So what does that mean you need to draw? A box. Yep. Okay. So 2x squared. Now, be careful here. They do not multiply to -5. What do they need to multiply to? Multiply.
Oh.
What do I do with these two?
10x squared.
There you go. And add to what, Brennan? You said it earlier.
9.
Oh, yep, sorry. Okay, so figure out what multiplies to -10, but adds to 9. Anybody got any options? What is it?
Adds a -10.
Multiplies to -10. So things that multiply to 10. 1 and 10 and 2 and 5, right?
10.
All right, I like 10 and 1.
-10 is 1. -1, 10.
1 negative.
No, 2.
Oh my gosh.
Oh, yeah.
So test it. If I multiply those, do you get -10?
What is that?
If you add it, do you get +9?
Yeah.
So those work, right? Okay. So 10x. All right, now be careful right here. It's not just x now. What's that greatest common factor?
2x.
Finish the puzzle. What goes up here?
X.
What about here? And all right, questions on the factoring. That's the first one on here that's had a number in front right there, but you've done it before. It's just been a while. All right, so tell me what goes on the bottom here. What is the fully factored green thing? Okay. And then 2x minus 1. What else needs to be out there, though? That GCF, right? Okay. Is everything factored completely? Not simplified yet, but factored. Okay. So tell me a factor that you see on top and bottom. All right. Definitely this one, right? So what can we do to those? Mark them out. Now, sometimes people miss this one. So tell me what two factors are left on top?
2x.
2 and x. Those are being multiplied. So those are two separate factors, right?
Yeah.
What factors are left on bottom?
X. 2x minus 1.
What circle on top and bottom?
2x.
An x on top and an x on bottom, right?
Yeah.
Does the 2 cancel with it? No. In order for that 2 to cancel out, I would need a what on the bottom? A 2. It has to be identical. Okay? Questions on that? That's what people forget sometimes. They forget to cancel out just the little x. So what is it? What y'all think? Is that what's left? Yeah. There you go. Okay. So if you can factor, you can do this stuff.